Let's study effectively with Miss ICT Skill Builder.
If a computer blindly accepts bad data, like a letter in a phone number field, the logic crashes. If it accepts a negative number for a bank deposit, accounts get corrupted. To stop that, robust systems rely on two distinct lines of defense: validation and verification. Validation is an automated check asking, is this input reasonable? It ensures data falls within set boundaries. Verification is a secondary check asking, is this an exact copy? It ensures the user hasn't made a typo during entry. A system requires both processes. An input might be mathematically reasonable to a computer passing validation, but still be an inaccurate copy of the original document, failing verification. We can see exactly how these defenses work by building a standard video game registration form. Different input fields require different rules. First, we need the user to create a gamer tag. We use a presence check. This rule simply ensures the field cannot be submitted blank. Next, we ask for their age. Here, we use a type check. The system expects a specific data format, an integer, like the number 16. It will immediately reject a string of alphabetical text, like the word 16 spelled out. Then, the user selects their lobby size. We use a range check. The input must fall mathematically between specific upper and lower bounds. If our limit is 1 to 4, an input of 5 gets blocked. Now they create a password. We apply a length check. It is easy to confuse length and range, but they evaluate different things. A range check looks at mathematical value, while a length check counts individual keystrokes. We need a minimum of 8 characters, regardless of what those characters are. If they have a promo code, we use a format check. The input has to match a predefined alphanumeric pattern, like 3 letters followed by a dash and 4 numbers. Finally, they enter a gift card code. This uses a check digit. The computer looks at the final number in the sequence and runs a background calculation on the preceding numbers to ensure they mathematically sum up to that final digit. It is designed specifically to catch typos. These 6 specific checks operate together as a highly specific, automated bouncer. They ensure no corrupted or illogical formatting breaks the database structure. Knowing the rules is only half the battle. We also need to program the system to trap users until they provide valid data, like forcing them to give us a valid lobby size between 1 and 4, without the program crashing. This algorithm snippet shows how we do that. We use a while or repeat loop to continually ask for input. Inside, we nest an if statement. If the input violates the boundary, the if statement triggers an error, and the loop forces a retry. Think about how you would build a presence check loop for an email address. You would check if the email variable equals an empty string. If it does, the loop runs and asks again. Combining iteration loops and selection statements is the core mechanical engine behind all automated software validation. Validation is strict, but it has a blind spot. If a user tries to set their password to Apple 1 but accidentally types Apple 2, that input perfectly passes the length and type checks. Validation accepts it, but it fails the user's intent. This is where verification takes over. One method is a visual check. The data is displayed back to the user so they can manually compare it against their original source or memory. This customer information form uses the double entry method. It forces the user to type their email and password twice, and the system runs a strict comparison to ensure absolute parity. Because purely mathematical validation algorithms are blind to human typing errors, verification acts as the necessary human error failsafe. Let's review how to classify these defenses in the real world. Validation relies on rules and bounds. Verification relies on accuracy and duplication. Scenario 1. A website asks you to enter your email twice. Why is this verification? Because it is a double entry check comparing two inputs for exact parity. Scenario 2. A pizza app rejects an order for -2 pizzas. What defense is this? That is validation. Specifically, a range check ensuring the number is above 0. Scenario 3. A form blocks your submission because you left the phone number blank. That is also validation, a presence check requiring data to exist. Mastering both the mathematical boundaries of validation and the exactness of verification gives you the complete toolkit needed to guarantee total data integrity in any application.
Thanks for watching. If this helped you clear up the concept, hit that like button and share it with a friend who might be struggling with it too. Let's build those skills together.